I've seen the barking dog probably 100 times, maybe more, and I've never noticed this before because it's just too fast for the eye to see. This reaction is one of our real favourites.
It's been carried out for many years as a demonstration to our students, and particularly by myself and some of my colleagues, but also by B.D. Shaw, Colonel Shaw, who used to do the Thunder and Lightning lecture many, many times.
And apply a light.
It's called the barking dog.
It produces quite a kind of a barking dog sound, a woof sound.
It involves a test tube, a really big test tube. This is just a model with a cork, and inside is a mixture of carbon disulfide, CS2 and N2O, nitrous oxide.
The flame shoots out the top of the test tube. So I guess you have this image of this flame coming up and consuming your hand if you leave it over the top of the test tube too long. And my first few goes, I was quite, you can see me flinching in some of the videos, but as I've done it now, probably tens, if not hundreds of times, I flinch less and less.
The combustion front races to the bottom of the tube, giving up this amazing whoop.
And normally what the audience sees is a great whoosh. The note just goes up like the squeak I made then.
It can be drawn out, it could be woof, or sometimes it goes much quicker.
But when you watch it in slow motion, it looks quite different.
Now, you may not have seen exactly what happened. What I observed was that although the flame started slowly, it built up speed as it went on.
I've never seen it using this really, really ultra-fast camera.
You still see the flame going down, but instead of going down in one great whoosh, it jumps up and down the tube. So it goes down a little bit and then up and down and up and down and so on. And as it gets nearer the bottom, it seems to go up and down more and more.
Okay, so we'll take the top off, we'll add a match. And I thought that this flame front used to go very, very smoothly from the top to the bottom, and hence the whoop. But actually what this video footage has shown us is that it actually goes in stages. It sort of goes doot, 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 doot. It sort of chugs its way to the bottom of the tube.
We weren't quite sure what was happening.
I think what's happening is the pressure wave is bouncing off the bottom of the tube.
Now, a number of very curious things are going on in this tube.
Imagine this hand here, the one with the watch, is the flame front coming down. And as it comes down, it gradually goes faster as it heats up and burns the fuel, and eventually gets to the stage where it almost explodes and sends a shock wave down to the bottom of the tube. When it gets to the bottom of the tube, it can't go any further. It's not strong enough to break the glass.
The only time it ever went wrong for me was we broke the bottom of the glass. So I guess that the pressure pushed the tube downwards and we broke the tap off the end. And I only know of that happening once, and it happened to me.
So it's reflected and comes up again, and then when it gets the flame, it gives it a push upwards. So the flame is now burning up here where there isn't quite so much fuel, and it gradually warms up again till it gets here where the fuel is rich, and then another shock wave goes boom, up again.
And actually, if you look really carefully, it looks like it's picking up speed as it goes down the tube. And I think that's because the distance between the flame and the bottom of the tube is getting smaller and smaller each time.
Boom, up, till in the end it's going really quite fast.
Well, we still have another tube prepared, and so you have another opportunity of observing this effect.
I've seen 2 or 3 barking dog experiments since then, but the flame front going down is really too fast to see this bouncing. And anyway, I'm too busy blocking my ears to really pay attention to the flame front. I think of all the slow motions that I've watched, that one was the most surprising, because you could have expected that cesium or rubidium would cause a big explosion, but none of us really expected this motion of the flame front. I suppose once you've seen it, you can think of an explanation. It's no longer such a surprise, but none of us were expecting it.
Okay.
All PhDs in some of these videos.
Every time you do a new experiment, you see something subtly different, and that just it makes you ask more questions.
Red circle.
Red circle, yep.
Ready on the trigger.
Ready? Yeah.